Mais ça, c'est parce que José Allois est tenant d'un ordre strict dans les choses de la connaissance. Ce séminaire profite de manière très très opportuniste à la fois de la présence de Kyle Harper à Paris, car il est invité au Collège de France pour cette année, sur la chaire Avenir commun durable du Collège de France, et de sa gentillesse, parce que je crois qu'à peu près tout le monde a voulu que Kyle fasse un séminaire maintenant qu'il était à Paris. Donc il a eu l'extrême amabilité d'accepter de le faire ici sur un thème qui permettait un croisement intéressant avec une autre scientifique de grande réputation, Tatiana Giraud, qui elle aussi a occupé une chaire biodiversité, je crois, du Collège de France. Donc Tatiana est en quelque sorte une amie du laboratoire, et elle a accepté de venir répondre sur une question formelle qui est l'influence du climat dans diverses choses qui nous touchent de près ou de plus ou moins près, qu'il s'agisse des écosystèmes auxquels nous appartenons ou qu'il s'agisse du passé de l'Eurasie. Et donc on s'est proposé d'avoir ce séminaire croisé pour voir si les questions peuvent à la fois se croiser, se répondre, et si on peut faire un des exercices d'interdiscipline que nous affectionnons. Et pour arranger encore la chose, José Allois, ici présent, je le désigne parce qu'il est responsable, a dit ça serait pas drôle que ce soit l'historien à présenter l'historien et le physicien a présenté la biologiste, parce que tout ça serait totalement attendu. Donc, il a pris le pouvoir sur l'organisation en disant « je présente l'historien et tu présenteras la biologiste ». Donc, vous êtes avertis, l'ensemble a été pensé comme un exercice de non-équilibre. Alors, j'ajoute que José, prenant sa tâche très très au sérieux, j'espère qu'il ne parlera pas plus de 6 minutes.
Une petite heure.
Voilà. Alors, j'ajoute qu'en aucun cas, il ne peut y avoir de débat après l'introduction de José sur qu'est-ce qu'il a voulu dire. Ça pourra faire l'objet de demandes après. Mais ça n'est pas lui l'intervenant. Lui va simplement introduire Kyle Harper. Et puis, selon la règle du séminaire, Kyle parlera une quarantaine de minutes ou plus. Nous aurons un bout de conversation. À ce moment-là, il sera sûrement plus de 14h45. Et j'introduirai en 15 secondes Tatiana Giraud. Et elle fera son intervention. Et puis ensuite, nous irons prendre du café ou des liquides, mais aucun alcoolisé, dehors, en discutant. Et la deuxième partie, ce sera une vraie table ronde, si je puis dire, c'est-à-dire que les questions pourront être posées et, dans le meilleur des cas, les réponses pourront être apportées. Et donc voilà le point. Après l'intervention de Kyle et après l'intervention de Tatiana, si vous avez des questions qui sont d'ordre factuel et non pas d'ordre herméneutique, vous pourrez les poser. Mais José et moi interdirons tout ce qui pourrait déborder sur le débat final. Voilà. José, tu as maintenant 3 minutes.
Merci, professeur Arnaud. So I would like to thank again Kyle Harper, Professor Kyle Harper from University of Oklahoma. Kyle Harper has given his lessons at the Collège de France in French, but today he's going to speak in American English, and I will introduce him in a broken English because it's easier for him, but the next talk will probably be in French. So today we are going to discuss about things that are changing in time and what is the best discipline to discuss things that are changing in time than physics. And then because the conception of time is a profound question in physics, and I will start by the simplest one, which is this one that most of you know, that paper published in November 1915. The field equation of gravitation by Albert Einstein. That was a completely new conception of time, embedding time in the fourth dimension of the fabric of the universe, 3 space, 1 time. And he has a very profound understanding of what that means. In a letter to his friend, to the children of his best friend, Michele Besso, that died, that passed away, he wrote a condolences letter. And the conclusion that you may read here, if you can read Einstein's writing in German, it's been translated below. He tells to the children of his friend, now he has departed from this strange world a little ahead of me. That signifies nothing. For those of us who believe in physics, the distinction between past, present, and future is only a stubbornly persistent illusion. So today we are going to address, our two guests are going to address that illusion called past, present, and future in the spirit of Albert Einstein. But that's not the whole story, because at the same time there is a strange guy, Georges Lemaitre, a Belgian physicist, who wrote this paper in French, which is always the classical mistake of people that try to be forgotten by history of science, is to publish in French in some unknown journal. And he was proposing that when looking at the equation of Einstein, the very same equations, there are particular solutions that point to the fact that the universe may be expanding. And if we go back in time, that the universe started from a point that he called the atome primitive. And that paper is the start of the idea of what is called now the Big Bang. What is interesting when he does that, in contradiction with Einstein at the end of the day, is that we have a history of the universe. Okay, it starts because there is some kind of beginning, so it's not a static universe, an expanding one. And so when you see that in the corridor, because this is the astrophysics level of the campus of this building, and you see those maps when you have a history in seconds, in minutes, and of course in billions of years. So at the end of the day, the universe has a history, whatever Einstein was thinking. But now the common misunderstanding by physicists is the block universe. They say, yeah, there is some strange kind of things that they look like it's changing in time, but not at all. Everything is already there. The block universe is everything is already there. Everything has already happened, and we are just moving in that strange space. I don't abide by that interpretation of Einstein equations. And I prefer to show you two of my favorite physicists, Philip Anderson. The fact that they got the Nobel Prize the same year in 1977, it's not by accident probably. Philip Warren Anderson got the Nobel Prize for his work on condensed physics. Is one of the founder of the complexity ID. And we have Ilya Prigogine, that was disappointed all his life because he got the Nobel Prize in chemistry and not in physics. But compared to Anderson, they had the choice, and then they choose chemistry for him, for non-equilibrium thermodynamics, and particularly the theory of dissipative structures. And those two Nobel Prizes correspond to each other from an epistemological point of view. First of all, as I said, Anderson is one of the physicists that goes against the Whiggish interpretation of the universe by the field equations, and is more discussing about complexity in this famous paper, More is Different. And there is a 50 years, just little article discussing that complexity matters. And in fact, Prigozhin was saying the same thing, kind of things in From Being to Becoming, which is one of my favorite books by Prigozhin. Some people that know me know that I'm out of this lab. And what is he saying is things are not, things are becoming. That's the main thing he was saying. And the other thing he was saying is what is written there. If we have a non-equilibrium system, it is interesting, I read that bifurcation induces a sense of history, here we go, into physics. Suppose that observations show us that the system whose bifurcation diagram is presented in the figure, that's a Nobel Prize lecture, by the way, blah, 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 and that implies, so it concludes, in this way we introduce in physics and chemistry a historical element which until now seems to be reserved only for science dealing with biological, social, and cultural phenomena. And these ideas of complexity and the fact that there is an arrow of time, there is irreversibility and an arrow of time, that the physical object have a history in the very same things as historians, lead us to the present day. That's one of the papers that is in press for the moment. And physicists of complex systems, which makes the links between the two talk, they use quantitative measures, whatever the evolving system is. And so they use the concept of fitness landscape, and then they discuss if the evolution is gradual, stasis, or punctuated equilibrium, like it's discussed in biology. But they show that, you see here, for the history of the Earth, they easily draw the only biological of geobiological Earth, and then they draw the same with adding human societies in it. Nothing different. Same business. After all, human societies are just embedded in Earth system, and we can compute phylogenetic trees of evolution of the system. Here you go, the same kind of question with the hornet structure. So it's the technology of the hornet is evolving in time. Then you can redraw quantitatively the kind of evolutionary graph, and the same for computer software. So for physicists in complex system, there is no problem in discussing computer program language, technological object, or the Earth system with the same way, because after all those things are the same. And so it's no surprise for me that today we are going to listen to two persons that discuss that, and they are embedded in the Earth system, and then they can argue if the physicists are so arrogant or not, and if that brings them some kind of ideas that can have an interdisciplinary look between physics, social science, history, and biology. So Kyle, the floor is yours.